Alrighty, this is Composite Figures Notes. So far in this unit, I've shown you basic area, and then we did area and circumference of circles last time I saw you. So now we're doing composite figures. We're going to put it together and do composite figures. A composite figure is a figure that can be divided into shapes. That are basic plane figures like triangles, parallelograms, trapezoids, rectangles, circles, etc. To find the area of a composite figure, divide up the regions and find each area. After you do that, you're going to then find the sum of the areas by adding them together. Very, very basic. We'll start them off with an easy one. Find the area of each of the figure for each figure below. Round to the nearest hundredths. Use 3.14 for pi. Crystale. Number 1. What shapes do you see that make up this composite figure, sir? Say it again. Just talk louder, man. A rectangle. And what else? A rectangle and a trapezoid. So crystally, we're going to find an area of a rectangle and area of a trapezoid. I abbreviate. And we're going to add those together. Let's start with the rectangular piece, crystally. How you find area of a rectangle? What's the formula? You don't need to look, you should know it. It's a little scary. It took you to. Crystale, what's the length of the rectangle? What's the width, Crystale? Put it in the calculator, you should get 276. After that, crystale, we want to go find the area of the trapezoid. Crystale, how do we find area of a trapezoid? That's not going to be it, but and see, this is why we should have been outside, but y'all lucky y'all don't have time. I'm not leaving, man. Hurry up, and I'm recording. Let's go. We ain't got that kind of time. Somebody else give it to him. Go ahead, Lucius. You missing something? No. Go ahead. Say the whole thing again. At least you came up with something, though, Lucius, unlike somebody else over here. Didn't even know where to start. Crystale, this is your problem. We're coming back to you. We're going to treat the half as divided by 2. What's the height of the trapezoid, Crystale? Uh-oh. How'd you get that? What? No. I can tell that's wrong. That was just a bad guess. Put that laptop up too, but go ahead. Say it louder for Crystale so he can hear. 18 minus 12 will give you the height of the trapezoid. The height is right here. 18 minus 12 will give you that. Crystale, back to you again. Base 1. Hopefully you get something right on your own. Come on, man. Avery, what's base 1? Talk louder. 15. Base 2. Thank you. Embarrassing. On video. After that, 15 plus 23 times 6 divided by 2. 114. After that, we want total area, so we're adding these two together. Say it again. 390 centimeters squared. That was supposed to be the easy one, guys, which it was for most of us. Chloe, it's time to kick in. Number 2. Tell me what all you see.
Triangle, rectangle, and half of a circle.
What you call half of a circle? You ain't never heard it be called that before? Somebody whispering it to you. Yeah, semicircle, semicircle. So on this one, I'm doing area of a triangle, area of a rectangle, area of a semicircle. First things first, Chloe, area of a triangle. What's the formula? For the triangle, what's the base? I'm gonna let you try that again. What's the base of the triangle? We can shop around on this one. Raven, you know? Huh? Oh, tell me why, Marky. Come on. There you go. 9 is the radius of this circle. This is 9 feet right here. This has to be 9 feet over here, which is my base of my triangle. Yeah, we cooking now. So that's 9. After that, we need a height for the triangle. Somebody should see that too. What's the height of the triangle? I'm listening. Tell me how.
Because if the radius is 9,
Yep.
you do 26 minus 9, and then if it's 7, you go to the
What she's telling y'all, this radius goes this direction too. This is 9 feet right here. So to get this height right here for the triangle, she did 26 minus 9. Also minus the 7 up here. That's where she gets 10 from. After that, 90 divided by 2. Area of the triangle is 45 feet squared. Then we get the rectangle. Let's remind Crystal again, Bird. What's the formula for a rectangle? Yeah, you should memorize that. So for the rectangle, we need a length and a width. What's the length? Say it louder. Teach them.
Because if the height of the triangle is 10, you just have to add 7.
Yep. 10 plus 7, 17 feet. Times the width. What's your problem? 9. Area equals 153 feet squared. Then we go find the semicircle. It's our first time dealing with one, but it won't be our last. Matter of fact, we're gonna do one on the problem below. Let's talk about a circle in general. How we find area of a circle? So how would you find area of a semicircle? No. Come on, use your brain now. Come on. There it is. Pi r squared divided by 2. 3.14 times, we know what R is, 9 times 9 divided by 2. Say it one more time.
127.17.
Yeah, 127.17. This is feet squared. Then we just need to add them up. 325.17. Light work. This should be easy for y'all. You know, on my test, I'm actually word problems. There's gonna be one similar to this one on the test. Luis is going to paint a basketball court in his driveway. The basketball court consists of a rectangle and a semicircle. They tell me which two shapes make up the court. If Luis plans to buy special coating for the basketball court at $23.75 a can, and each can covers 20 square feet, how much is Luis going to spend? Figure out how much it's going to cost him to paint this court. First thing we need to do is figure out the area of the court. I already told you what shapes they were. Area of a rectangle plus area of a semicircle. Alright. Area of a rectangle, we done did it 2 times already. Length times width. We'll make this yours, Isabella. What's length and width? 10 and 8. Easy math. 80 feet squared. Then after that, we're doing area of a semicircle. We're going to use the same formula me and Bird just used. 3.14. What's the radius, Isabella? Radius is 4 times 4 times 4 divided by 2. 25.12. After that, we want our total area of our court, so we're going to add those together. Yep. Area of the court would equal 105.12 feet squared. So that's what we're working with, 105.12 feet squared. You okay with that, Christella? You're going to have to be anyway. After that, we want to figure out first how many cans of paint we need to buy. To figure that out, we got our total area of the court. 1 can covers 20 square feet. We'll divide that. 105.12 feet squared. Yeah, divided by 20 feet squared. And like she said, you're going to get 5.256. The question then becomes, how many cans of paint do we need to buy? Say it louder. 6 cans. After that, you just want to figure out how much money you're going to spend. Times it by the money. I'll never tell you how to round on a money problem because money is always in what decimal place? Hundreds. So your answer should always be in the hundreds. So when you read your answer, read it as money. What's the answer? And how many cents? 50 cents. There you go. They just don't put the zero there. $142.50. Good. We're cooking right now, kids. That's composite figures. On the back, I'm gonna show you shaded area or shaded regions. Easy too. You just go in reverse. Shaded regions. To find a shaded area, let me read that again. To find the area of a shaded region, find the area of the, I don't even know where it's supposed to go there. Hold on, let me see. Shaded figure. Yeah. Then subtract the area of the non-shaded region. So it makes sense. Your shaded figure is probably going to be the one bigger one because you're going to put the non-shaded area inside. Find that first, find the other figure, and then subtract. It's pretty straightforward. Matter of fact, let's bother Aiden. Aiden, on number 4, what 2 shapes do you see? What's the bigger shape? A square. So we're doing area of a square minus, what's inside the square? A circle, area of a circle. We're going to do that. So let's do it. How we find area of a square, Aiden? What's the formula? Very simple one. Think about it. Yeah, just a square. So, well, side squared. S squared. Gotcha. Area of a square is S squared. 25 times 25. Is that 125? I think. No. Is that one? No, it's bigger than that. 625. I don't like how I'm about to write that. I'm about to white out. $6.25. Alright. After that, Aiden, we need area of a circle. Remind me of that formula again. We used it on the front a couple times. Think about area of a circle. Pi r squared. Yes, sir. A equals 3.14 times, what's the radius? 12.5. So times 12.5 times 12.5. We're not rounding that decimal either. Yeah, 490.625. After that, we want to find the shaded area, so we are subtracting these. Get our shaded region. $134.375. This will be feet squared. Light work. Landing on number 5. What's your bigger shape? Yeah. Rectangle. What's the smaller one? So you're doing area of a rectangle minus area of a triangle to find the shaded area. You do that. You should know both formulas. Chris Solid, what you got for now? What's your shaded region? Janae, what's that? Alright, let's go over to the next one. Alright, number 6. What parameter? Well, I can't read. What is the perimeter of a rectangle with vertices C, D, E, and F round to the nearest hundredths? Graphing. -1, 1, 3, 4, 6, 0, and then 2, -3. You've seen me graph many times. You know I label C, D, E, F. When most kids graph this, they usually say what I expect them to say. What did you think when you graphed this, Chloe? Well, I know. When you first graphed it, what did you think? It looked like a rectangle?
No, it looks like a square.
Yeah. Most people, when they graph it, say this is not a rectangle, this is a square. But I taught y'all quadrilaterals unit, so are they wrong by calling this a rectangle? Because isn't a square a rectangle? A square is a rhombus, a rectangle, what's the other one? Parallelogram, it's all of them. Now in reverse, if this was a rectangle, I couldn't call this a square. Because a rectangle is not a square. But a square is all every kind of parallelogram. So they're not wrong by calling this a rectangle. It's not as accurate. More than likely, this is a square. I'm gonna check though, make sure it's a square, and then I'm gonna just do my math very easily. So I'm gonna just check to make sure I think this is what I think it is. C to D is 3 and 4. Looks like Chloe said we're doing perimeter, so we just need to find the length of all the sides. D to E is 3 by 4. E to F, 3 by 4. So yeah, definitely a square. Since it's a square, how many times I got to do Pythagorean theorem? Well, after I do that, logically to find perimeter on a square, what would you do? Say it again. Times how? Oh, I thought you said 3. Yeah, times 4. Yeah. Just multiply times 4. So I'm going to do Pythagorean once. And before we start, I've been trying to, especially since y'all honors, I'm trying to mention this to y'all. This is one of those common Pythagoreans. Whenever I see these numbers, like, I already know the answer to this one. This is a common triangle that y'all see a lot in Pythagorean. If you start to notice the numbers, you probably save yourself time because you won't have to show your work. But 3 squared, 4 squared equals c squared, 9, 16, c squared, 25, c squared, square root. Square root is going to be 5. C equals 5. This is a 3, 4, 5 triangle. I've mentioned this to y'all before. It's a common one. A 3, 4, 5 triangle is a common Pythagorean. Another common one that you'll see is 6, 8, 10. Another common one is 9, 12, 15 that you see a lot. And then 5, 12, 13 is a common one too. Pythagorean triple. When I see those numbers in when I'm doing Pythagorean, I like automatically know what the other number is gonna be. Sometimes I don't even show my work because I just know. So my perimeter is gonna be 5 times 4, like Marquis said. Perimeter equals 20. This easy behind question will be on your test. If you want me to be honest, I don't even think I changed the numbers. I might. I can't remember. No, I don't think I did. I might put the square in a different spot, but it's still going to be a square. Calculate the area. This is the one I want you to see. Did you figure this one out without me? What you got? Huh? Oh yeah, you did figure it out without me. Look at you. Calculate the area of a triangle with ABC with the altitude of CD, given A, B, and C, and D. So the triangle itself is ABC. They gave me an altitude on this triangle, which is my height of CD. Alright, graphing. My first time showing you one of these. You'll see it 2 more times before we take the test. This will be on your test. Not a hard problem, but you need to see it done. -6, -4. B is at 6, 5. C is at -1 up 6. A, B, C, and then point D, which is on my triangle, is here at 2, 2. My triangle itself, though, is ABC. D is just a point on the triangle. And my triangle, on that triangle, they're telling me CD is my altitude. Well, that's somebody else besides Chloe since she's done. On this one, they wanted us to do area of this triangle. It's on the graph, but we still can do area. I'll remind you again, area formula equals 1/2 base times height. Raven, I'll ask you, Raven, for this triangle, we need a base and a height. What side would represent the base? A to B would represent my base. And what would represent my height? CD. Well, I'm saying that so y'all can identify and understand. Y'all need to find AB and y'all need to find CD. You're doing Pythagorean to find both of those. So do AB first. That's your base. What's up? Oh, I thought your hand was. Oh, you scratching. AB. We can count it or we can cheat it. A starts at -6, goes over to 6, 12. Vertical here, it goes from -4 to +5. That's 9. So 9 and 12. I'm gonna do Pythagorean right out here. 9 squared, 12 squared. I just mentioned this is one of them common ones. 81, 144. C squared, add those together, 225. C squared, square root. 15 equals C. So my base is 15. And then I go back and find my height. My height is going to be my altitude right here. You can do your triangle either way. I'm going to go this way with it. I'm going to go here, then here. Crystalli, once we count this one, it should be obvious to us. It's 1, 2, 3, 4, and 3. This is a common one. Crystalli, what's my answer going to be without even doing the math? You ain't been paying attention, so I know you don't know. 3 squared plus 4 squared equals C squared. We just did it on the last problem, my boy. 9, 16, C squared, 25, C squared, square root. 5 equals C. My height or my altitude would be 5. $15 times 5 divided by 2. This is where Chloe got 37.5 from. You will be asked to do one of these. I've seen this on y'all ELC too. Now I don't know if they're gonna change these questions or whatever, but they are gonna ask y'all to do this type stuff. Not hard. If I can get y'all to work on the graph good, then y'all should be straight. Be able to do parameter and area on the graph. I can guarantee you a decent score. Let's keep it moving. On the practice, lucky you. I'm gonna do a couple problems on here. We're gonna talk. That's why I need to update this video. Find the area of the figure below, round to the nearest tenth if necessary. On this one, have I not bothered yet? He ain't a good person. I don't bother pretty much everybody. Devin, let's go. Devin, it's a composite. What shapes you see though? Say it again. Rectangle and what else? Just one? 2? So when you saw this, Devin, you do area of a rectangle and then what, area of 2 semicircles? Oh. What's more logical? Area of a rectangle, do area of a circle. 2 semicircles equal a circle. I'm gonna help y'all out though, because I want to make sure y'all get y'all measurements right. Let's start with the semicircles. What's the radius of those circles? Or semicircles? Say it again. Teach me.
Because if the base of a rectangle is 20,
Uh-huh.
then you split, or if you divide 28 by 2, that's 14.
Uh-huh.
So then you have 14.
Yeah, so she's saying this base right here is 28. She sees these 2 semicircles are right next to each other. They both have a diameter here and here. She split it in half. She got a diameter 14 here, a diameter 14 here. And then she divided those diameters by 2. Got radius of 7, 7, 7, 7. Okay, so your radius is 7. My other question to you is, what's the width of the rectangle? Say it again. Teach me. Yeah, radius also goes up this direction. We don't want to forget. 24 minus 7 will give us 17 meters. Alright, I just wanted to help y'all out on that one. I made it easy for you. Number 2, I'm going to do this one with you. It's your first time seeing a big circle, little circle problem, but you're going to see many of these. I love asking this question, these type of questions. Asphalt pavement costs 78 cents per square foot. Determine to the nearest cent the cost of paving a shaded circular road with the center at O, and outside radius of 50 and an inner radius of 36 as shown in the diagram. So on this one, they want to pave this asphalt road right here, circular. The shaded area is the road. We need to figure out how much asphalt we have so we can figure out what it's going to cost. Just 78 cents per square foot. Okay. On this one, the shapes are circles. You got a big circle and you got a little circle. Get those and then subtract. I'll find the shaded area. So, start with big circle. Big circle. Crystal, remind us again how we find area of a circle. They should be in your memory bank, son. Pi r squared, son. It'll never change. Area equals 3.14 times my big radius is 50 times 50. This is a clean answer for some reason. Chug it. $7,850. Yeah. And then after that, we do a little circle. Crystal, how we find area of a circle again? I was just checking, see if I can get you. A equals 3.14 times 36 times 36. Point what? 44 feet squared. Alright, so those are my two areas. It's big circle, little circle. To get the shaded area, we're subtracting these. Thank you. This is the shaded area, and this is the area of asphalt. To figure out how much it's going to cost to pave this amount of asphalt, we're going to multiply by 78 cents per square foot. So times 78 cents. Remember, we're dealing in money, so our answer is going to be in money too. Say it as money. I'll say it for you. $2,948.84. Oh, I used to be real bad about it. I used to make them. I wouldn't like go on until they said it correctly. They used to be real mad at me. Two more I want to show you. Number 3, be on your test too. Shoot, something like number 2 gonna be on your test. Everything I'm pretty much showing you, honestly, you're gonna see something. All the stuff we're doing today is pretty much like test questions. Number 3, overhead design of a baseball field is shown in the coordinate plane. Management wants to install a sprinkler system to water the entire field. To the nearest tenth, what would be the total area that needed to be watered? So they got the shape of the baseball field. They got it on the coordinate plane. They want to figure out what's the total area that need to be watered if they put sprinkler systems in to water the baseball field. To figure that out, you need to find the area of the baseball field. To figure that out, you need to figure out what shapes you got and break it in to pieces. Landon, what two shapes you see, man? I agree. Area of a semicircle. And then you said triangle. We'll do the triangle down here. Area of a triangle. Should have gave you out more space on this one, but we'll work with it. Landon, semicircle. How about I find area? Area equals what? That's it? So we need 3.14 times. Landon, we need a radius of our semicircle. No. You can just count, bro. It's on here straight. I just need you to find the middle and count. Yeah, radius is 4. Four times 4 divided by 2. We did this one earlier. I remember this number. At 25.12. After that, we need to do area of a triangle and add those two together. Area of a triangle. Remember the formula for that, Lana? Yep. Area equals, going to divide by 2. For the triangle, we need a base and a height, Landon. Yeah, your base is going to be 8. And then your height of your triangle would be 4. That's the reason I'm going to show you this problem. I'm going to give you one like this on your test too, but I want you to understand everything can be counted. We did this and we didn't do any Pythagorean or anything. All this on the graph straight. It can be counted. What's up, Lucius? You will divide by 2, man. It's half. It's all good, bro. 8 times 4 divided by 2. 16. Only issue I have with y'all when y'all do this problem, y'all don't read the end. So, of course, we're adding those together, but it says round to the nearest tenth. 41.1. If you add them together, you're going to get 41.12, but I told you to round to the nearest tenths. Last but not least, number 4. A design for a logo is shown. The company wants to create an outline of the logo and steel tubing for a sign. How much steel tubing would the company need? Round your answer to the nearest thousands. So on this one, it don't tell me exactly what to solve for, but it give me some key words here. It says they're designing a logo. It says the company wants to create an outline for the logo with steel tubing for a sign. They want to know how much steel tubing they would need. What am I solving for on this one? Say a lot of perimeter. Good. I'm not always going to tell you straight up. You're going to need to be able to read and figure out what I'm asking you for. On this one, I'm asking you for perimeter. Yeah. I wouldn't ask you for area on a shape like this anyway. That would be killer for y'all. But looking at this, I notice most of my sides are slanted, but this one side over here, it is straight, so I guess I can count that. We can start there. 1, 2, 3, 4, 5, 6. That side right there taken care of is 6. We need to find the other 4 sides. The other 4 sides, we are going to have to do some Pythagorean. I'm just putting that down here because I'm going to put all the ones I'm going to add together down here at the end. Over here, I'm going to run my Pythagorean down the side as we go. It's not labeled, but I'll just go line by line. Let's start here. My count on this one is vertical 3, horizontal 1, 2, 3, 4, 5, 6. 3 and 6. Let's start there. 3 squared, 6 squared equals c squared. 9, 36, c squared. Add those together, 45, c squared, square root, square root. You can try to do square root 45 in the calculator. It's going to be ugly, so we're going to leave it as is. Square root 45. That's the next one I'm adding in down here. Plus square root 45. Then I'm going to come back, get the next one. Nope. My next triangle. 1, 2, 3, 4, 5 across the top. Vertical here. 1, 2, 3, 4, 5. 5 and 5. 5 squared plus 5 squared equals c squared. 25, 25, c squared. Add those together, we're going to get 50, c squared, square root, square root. Square root 50 is an ugly decimal too. We're going to leave it as is. Down here we're going to add that in. Plus square root 50. Next one we're going to do is this one. Three at the bottom on the side here. 1, 2, 3, 4, 5, 6, 7. 3 squared, 7 squared. 9, 49, c squared. What's that? 50, 58. Thank you. C squared, square root, square root. 58 ugly too. We're gonna leave it as is. Last one we need is gonna be this one. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 3 and 8. 3 squared, 8 squared, c squared. 9, 64, c squared, 73. C squared, square roots. 73 ugly too. We're gonna leave it as is. Last one we're gonna add in is square root 73. Why just put my black pen in it? Now, if you got a more scientific calculator than mine, you can just type all in that in the way it looks. If you're using my calculator, that's how you would do it. There's a calculator. 6 plus 45. You need to take square root of 45. Square root of 45 is this decimal right here. My calculator remembers I already did 6 plus. When I hit plus again, it's going to add that in with the 6. Turns to 12.75. Then I'm going to do 50 next. 50 square root. That's square root of 50. Once I hit plus, it's going to add a 12.7 into this. 58 square root. Once I hit plus, it's going to add this into that 19 point whatever you just saw. And then 73 square root. It's going to add that in with everything else. Once I hit equals. To the nearest thousands. 35.939. Let me make sure I ain't got enough to show y'all. I think I'm good. Oh! On the one on the back. Let me do some setup. Let me get this on camera. On this one, very easy problem. It's just sometimes y'all be tripping, so I'm gonna help y'all not trip. I'm not even gonna say that. I'm gonna just do this, and I think y'all know what this means. A, B, C. Yeah. I got time, and I'm making a video. Let's go ahead and do that last one. So I want to have to help you on the other shoot too. Now, because y'all honors, I'm giving y'all both of these. The main focus is to finish 96 and make sure you submit that. But after that, you can roll right into 97 because 97 is pretty much the same, except for I just got a couple extra problems on there, and they're all the same. Nah, they're all the same. I'm about to just show you the one that's different. So I gotta show the other classes when they come back. But 2 and 3, I told them the only ones they couldn't do, but I'm gonna do these with you right now. 2 and 3 are the only new thing on this sheet. Everything else is something I did on that previous sheet. I said 2 and 3. It's not 2 and 3. It's 2 and where the other one at? Oh, 9. I'm gonna do 9 though. Honestly, y'all smart enough. But kids was doing this without me, but I'm gonna do it because I want to do it on video. A famous car owner. A famous car owner, Carroll Shelby, has been designing a exhaust tip for the new edition for the Shelby Cobra. The design below is a side view of the exhaust tip. If an artist were to design the figure below in two-dimensional form, how much material would be needed to the nearest thousands? Create the height of the trapezoid. To create the height of the trapezoid, to create it, if the height of the trapezoid was 9.25. On this one, the height is going to be 9.25. You find the area of the trapezoid. We're doing area. Huh? Yeah, give me a second. Let's do area. Oh, Cristale, one last time, bro. How we find area of a trapezoid? You still looking around for notes. How you find area of a trapezoid? Yeah. We ain't got that kind of time, son. In this problem, they told me height of the trapezoid. They told me it was 9.25. The thing you should realize when you figure out you're doing trapezoid, you need base 1 and base 2. You should see where they are on here. So you should see what size you're doing Pythagorean on. Because none of these are straight. Most kids do see this. You're doing Pythagorean on this side and this side right here. I start with the small one because I always figure my small one to be base 1 anyway. Here to here. I need this. This is 1, and this is 1, 2, 3, 4, 5, 6. 1 and 6. I'll do it here. 1 squared plus 6 squared equals c squared. 1, 36, c squared. Add those together, 37 equals c squared. I know I can't take square root of 37. It's not going to come out clean. So I'm going to leave that at square root 37. Square root 37, and then I'm gonna find my other base. My other base is gonna be this one over here. Here to here. This is 2, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 and 12. 2 squared, 12 squared equals c squared. 2 squared is 4. 12 squared is 144. C squared, add those together, 148 equals c squared. Square root, square root. Square root of 148 is going to be a decimal too, so we're going to leave that as is. I'm going to just put that as my base 2. Square root 148. There we go. We cooking now. After that, it's just putting it in the calculator correctly and rounding to the nearest thousands. That's 3 decimal places. In a calculator, you want to start with your square roots. That's PEMDAS, order of operations, parentheses. We had 37 square root plus 148 square root equals. That's those added together. times 9.25 equals that. Don't forget to divide by 2 to the nearest thousands. 84.398. Alright, that is the last one I'm going to show you. I'll put you in position. Your focus is 96. Finish those 5 problems I didn't do on that first. Submit that. That should be done before